In this video, we'll look at the rules for addition and subtraction of fractions. You'll see two different lists on this slide that detail the steps to do addition and subtraction of fractions. However, what I want to make clear from the beginning is that these lists are almost identical. Only the third bullet point is different. Under the addition list, you see that number 3 says to add numerators. Under subtraction, it says to subtract. So the concepts are very much the same. You just add or subtract as you need to. So let's go over the steps. First, change mixed numbers to improper fractions. Step 2, change common denominators using equivalent fractions. 3, add numerators or subtract numerators if you are subtracting. Step 4, reduce the resulting fraction to lowest terms. And finally, match the question for either improper fractions or mixed numbers. Pay attention to how the question states their units, whether they are in improper fractions or mixed numbers, and then match appropriately. So we've done some of these things individually. We've studied equivalent fractions, and we've also looked at how to go from mixed numbers to improper fractions. So in addition and subtraction of fractions, we're going to be putting some of those things together. Let's see how that works. Before we get into the details of how the addition and subtraction works, let's look at a very common question. Why can't we just add the numerator and denominator and that be the way it works? For example, let's say we have 1 over 2 plus 1 over 4, and let's say that equals 1 plus 1 is 2, over 2 plus 4 is 6. Let's take a look at that. So that would reduce to 1/3. So what we can see, if we look at this from another point of view, these will not be the same. Take a look at this picture where we have illustrated a 1/2 and a 1/4. If we were to add these together, we are going to add up the shaded regions. This is a very simple example, and what you can see is that the 1/2 plus the 1/4 should give you 3/4 of that circle. However, if we look at the answer we got, we had 1/3. So this doesn't work out. So these can't be equal, and that means what we did before can't be right. In math, if you're doing something correctly, you should always end up with the same answer as someone else who did their solution correctly. So all the pieces have to be equal before you can add or subtract fractions. So if we look at our first circle here, it's subdivided into 2 pieces, whereas the second one is subdivided into 4. So what we need to do before we add is to take the first circle and actually make 2 more divisions so that we make it out of 4. So that looks like this. So if we're making 4 divisions, now we have to make an equivalent fraction to something over 4. So the equivalent fraction looks like multiplying the top and the bottom by 2, because multiplying the bottom, the denominator, by 2 brings us to 4, which is how many subdivisions that we need. So now if we're adding these together, and all the parts are the same size, we can say 2 over 4 plus 1 over 4 is 3 over 4. So we had 2 pieces out of 4, we got 1 more, so we have 3 out of the total of 4. Now let's look up close at how making a common denominator works for fractions. You can do addition or subtraction of fractions with any common denominator. However, the lowest common denominator will usually be best. It keeps your numbers the lowest they can be, and it keeps you from maybe having to do extra reducing at the end of your question. So let's take a look at our first fraction, which is 4 over 9, plus another fraction of 7 over 15. So before we can add these together, we need to find a common denominator between 9 and 15. What that means is we're looking for the lowest common multiple between 9 and 15. So let's list out the multiples of 9 and the multiples of 15. We'll see 9, 18, 27, 36, 45, 54. Multiples of 15 are 15, 30, 45, 60, etc. So what we do is you go through that list and you find the first number that's common. So in this case, it's 45. So 45 is going to be the number we use as our lowest common denominator. So now we need to make an equivalent fraction that matches 4 over 9 to a fraction out of 45, and 7 over 15 to another fraction over 45. So that looks like multiplying the first fraction, top and bottom, by 5, and the second fraction, top and bottom, by 3, because 9 times 5 brings you to 45, and 15 times 3 brings 15 to 45. And then because when you do an equivalent fraction, you do the same thing to the top as you did the bottom. So that's why the 4 gets multiplied by 5 and the 7 gets multiplied by 3. So 4 times 5 gives you a 20, and 7 times 3 gives you a 21. And now our denominators are both 45. Now we're allowed to add the numerators, and remember to keep the denominator the same. So 20 plus 21 equals 41 over 45. So if we could try and reduce this fraction. However, 41 is a prime number. So this one cannot be reduced any further, and it's also a proper fraction because 41 is less than 45, so we don't have to worry about simplifying or doing any extra conversion. Now let's take a look at an example of subtracting fractions. Like I said at the beginning of this video, the steps are exactly the same except for when it comes to dealing with the numerators, we're going to subtract instead of adding like we did in the last question. So we'll start by finding the lowest common denominator between 10 and 8, our two fractions. So we'll list out those multiples again. So we'll have 8, 16, 24, 32, 40, 48. And the multiples of 10 are 10, 20, 30, 40. The first one common in that list is 40. So that's what we'll take. So the next step is to make two fractions that each have a denominator of 40, and they must be equivalent. So 10 times 4 will bring us to a 40, and 8 times 5 will bring us to a 40 as well. So that means we do top and bottom on both sides by the respective 4 and 5. Doing the multiplication, 7 times 4 is 28 in the top, and 2 times 5 is 10 in the top. And now we have common denominators of 40. So this is the step where now we subtract. So 28 minus 10 will leave us with 18. 18 over 40. Now this fraction can be reduced, however, because 18 and 40 are both even, so we can at least divide out by a 2. Like we did in an earlier video, if you'd like to do the prime factorization, then 18 can be written as 3 times 3 times 2, and 40 is 5 times 2 times 2 times 2. So the common numbers between top and bottom are only a 2, and that's what we take out. Our final answer then is 9 over 20.